Okay, in this video we're going to solve problem 11 on the final exam review. It has solving exponential growth and decay problems using the formula y equals a times b to the x. Now in a growth and decay problem, a is the initial value on this one. So a equals initial value. And b is either going to be 1 plus the rate, that's a decimal. If it's going to be growing, this is growing, or it's going to be 1 minus the rate as a decimal if it's decaying. So in this problem it's growing at 2%, so we're going to add 0.02 to 1 for the b value. Over in this problem, when it's saying it's decreasing or decaying at 7%, we're going to go 1 minus 0.07 for that one. So that's just a kind of a start of what we're going to be doing. What we're going to be using y equals a times b to the x value for each of these. Alright, so on letter A, we're going to write the model. We know initially that we have 150, so 150 goes here as A, and we're growing at 2% per minute, so we're going to 1 plus 0.02, and then we'll have an x here. So basically 1.02 to the x power times 150 is our equation. Alright, that's part A. It's our population equation. Y is the population, x is the time in minutes. Alright, so equal time in minutes, and y is the amount of population, number of bacteria. Okay, so second part of A asks you to find how long does it take to get to 5,000. So what we're going to do here is we're going to take this equation and put 5,000 in for y and solve this equation for x to figure how long it takes in minutes. So the first step here is to divide by 150. We have to get it in the right format. So we divide 5,000 divided by 150. That's 33 1/3, which is the fraction 100 over 3. So we're going to have 100 over 3 equals 1.02 to the x power. We're going to take the log of both sides. Now we don't have e here, so we're just going to use the regular logarithm. Alright, that's going to come down in front, so we're going to have x times the log of 1.02, and then we're going to divide by that logarithm 1.02 to get the answer for x. So we're going to have the log of 100 divided by 3 divided by the log of 1.02. And let's put that in the calculator and see how many minutes that is. So log of 100 divided by 3 divided by the log of 1.02 gives us 177 minutes approximately. 177.1 minutes. 177.1 minutes. to reach a population of 5,000. All right, and now it says compare that to the rule of 70. Oh wait, it says algebraically, so we haven't done part 3 yet. Algebraically find the doubling time and compare it to the rule of 70. All right, so let's do that next. So over here, we're going to take this and find a doubling time. So instead of writing 5,000 here like we did in this part, we're going to write 300 because that's double the 150 start value. So this is going to be the start of letter III here. So we're doubling it. So this is what we get. We divide by 150 and we get 2 equals 1.02 to the x power. And we're going to take the log of both sides as we did in the previous problem. We're going to bring the x down in front as we can with the property of logarithms. And we're going to divide to get the answer for x. And we're going to take our calculator and we're going to find that out. Log of 2 divided by log of 1.02. And we get 35, approximately 35. So 35 years, or 35 minutes for this one. 35 minutes to double. And it asks us to compare that to the rule of 70. Well, the rule of 70 is 70 divided by the percent. The percent was 2%. So 70 divided by 2 is also 35 years, or 35 minutes. So we get exactly the same number. It was very close on this rule of 70. So 70 divided by the percent is 35, which is what we got by solving the equation. We got really close to this. This was 35.002 something. So very close to the right estimate there. All right, now in part B, we have $10,000 decreasing at a rate of 7%. So we're going to do that, but we're decreasing. So our equation for part B is going to be y equals 100,000 for the initial amount, 1 minus 7% to the x power. So we're decreasing at 7. And we're doing that. So that's where we use the rate of 1 minus, or b 1 minus a rate. Okay, so our equation is going to be this. So y equals 10,000, 0.93 to the x power. Now in part 2 of this problem, it wants to know, this is part 1 of the problem. In part 2 of the problem, it wants to know when does it reach 2,500. In part 3, it wants to know what it's worth after 3 years. So when does it reach 2,500? So part 2, we would put 2,500 here equals 10,000, 0.93 or 0.93 to the x, and solve. So the first step here is to divide by 10,000. So we're going to move the decimal 1, 2, 3, 4 places. 1, 3, 4. So that's going to be 0.25 equals 0.93 to the x power. Take the log of both sides as we did before. Log 0.25 equals log 0.93 to the x power. Move the x down in front as the property of logs say. And we have to divide. So we do this the same way every time we're solving. There's not much difference in the process. The process is basically the same. We're just changing the numbers to get the x value. So let's find out what that is approximately on our calculator. I must have closed my calculator. Let's see. All right, so we're going to take log of 0.25 divided by log of 0.93, and we get 19.1. 19.1, and we have to figure out what the time was up in the original problem. It said in years, per year, so 19.1 years for this one. The other one was in minutes. This one is in years. So it takes 19.1 years to get to the 2,500. You'd have to lose that money for 19 years to make it down to $2,500 from 10,000. Okay, the last question here on this one is, what is it worth after 3 years? Well, it should be relatively not too small amount, so we can go back to the original equation right here and put just 3 years in for x. So for the third part of this problem, we're just going to put in 3 for x and figure it out. So we'll just type that into the calculator. 10,000 times 0.93 to the third power, 3 years. So 8,043 and 57 cents. 8,043, 43 and 57 cents. So this is how much it's worth after 3 years. So using the formula, we can just plug in the number of years for x. So that is problem 11 on final exam review.